Hello. In this example, I want to use the change of base theorem to find an approximation to 4 decimal places for each logarithm. A says log base 5 of 17, and B says log base 2 of 0.1. Now notice that I cannot simply figure out what these are by converting these into exponentials. And the reason why is because 5 and 17 don't share a common base, and also 2 and 0.1 don't share a common base. Now, the question you should be asking yourself is, what do you mean by the change of base theorem? Now, mathematically, here's what it means. It means log base b of a is equal to log base c of a divided by log base c of b. Now, don't freak out. Basically what this is meaning is that you can have any base converted into a ratio of any other two bases. Or excuse me, a ratio of two logarithms of a different base. So, whatever base you choose, just remember that your argument is the argument in the numerator and your base is your argument in the denominator. Okay, so the argument there is the argument of the numerator, and the base here is the argument of the denominator. Now, if we look at A, what we have on A is log base 5 of 17. So what I'm going to do is I'm going to choose a different logarithm, and then the arguments are, the numerator argument will be 17, and the denominator's argument will be 5. Now, I can choose any logarithm that I want. I can use log base 2, log base 3, log base 4, log base 30,000 million billion trillion. It doesn't really matter. But your calculator only has 2 logarithms on its faceplate. So what you're going to want to do is you're going to want to choose either log or natural log of either log or natural log. And because of that, you'll be able to type this into the calculator. Now, realize it does not matter if it's log 17 or natural log of 17 over log 5 or natural log of 5. As long as both of these are the same logarithm, it'll work out. So notice that log 17 over log 5 will actually give you the same thing as natural log of 17 over natural log of 5. So at this point, what you need to do is you need to get your trusty calculator out, which hopefully is trusty, and then you type in what you see there. So do log 17 over log 5. Now I'm going to do alpha y equals enter, just so you can have a ratio there the way that you see it here. So it's log 17 over log 5. And then just click enter. Now it's 1.76, 4 decimal places I believe, so 1.7604. But let's go ahead and check that just to make sure that if we do that with the natural log of 17 over the natural log of 5, you'll get the same thing. Hey, look, you do. So what you get here is 1.7604. 1.7604. Now notice that this is the approximate value. This is not an exact value. Let's look at B. B is log base 2 of 0.1, which tells me I can do either natural log over natural log or log over log. So I'm going to go ahead and just do natural log of 0.1 divided by natural log of 2. And the reason I want to do this is because if you remember from the last example, we had something that was over a natural log divided by a natural log. Basically what happened was the formula that you would have seen before this would have been log base 2 of something. And they simply used the change of base theorem to make it into either a ratio of logs or a ratio of natural logs. In this case, they chose natural logs. So if I do alpha y equals enter, and I type in the natural log of 0.1, by the way, natural log of 0.1 is negative, over the natural log of 2, which is positive, so negative over positive should give you negative, which will be negative 3.3219. So that's negative 3.3219. One other thing, if your calculator is new enough, you can actually check these another way. So if you go into Math and you go up until you see log base, you can click Enter. And then you can physically type in log base 5 of 17. And really all this is doing is it's using the ratio of log 17 over log 5, or natural log of 17 over natural log of 5, I'm not sure which. But notice that it does give you 1.7604. And then again, we can still type in log base 2 of 0.1. And that also gives you negative 3.3219.